sometimes there's no way of avoiding illnesses, and I've got I'm on antibiotics right now, and they are doing a lot of good. I feel a lot better today than I did yesterday or the day before, but they take time. And I don't think it would have been a good idea for me to physically come to class because, well, first, I'm not physically up for it. I don't think I would make it through the entire 5 classes I teach. And secondly, I don't want to give you what I've got. And so for everyone's health reasons, I had to avoid it. Now, I can't make any hard and fast predictions. I've given up trying to do that with this thing. But as soon as I am physically fit, I will send you out an email that night. So if on Wednesday night I say, yep, I'm ready to rock and roll, I will send you out an email saying, hey guys, you finally get to see me and we're now back to normal. But I've already had the one relapse with this bloody chest thing. So I don't want to make big promises and I'll feel okay on Tuesday and say, hey guys, I'm coming, and then I don't. So I won't make any commitments till I know I'm ready. And that'll kind of mean that you're going to have to live day to day, right? So we don't know how it's going to work. I've, based on some things that I've heard from other people, yeah, I was just reading some comments that people put there. I have made some changes based on what some people have told me. And that's mostly to do with them having a real hard time with this number crunching process. And I don't want you to get too caught up on, the forest and the woods thing. These are numerical methods to estimate the area under the curve, but they are not the most important part of Calc 2. And the analogy would be, remember in Calc 1 where you try to find the slope of a tangent line by doing numerical, from 1 to 1.1 and 1 to 1.2, and you made it narrower and narrower. You did a whole load of number crunching there to get a better and better estimate for the slope. All we're doing right now is finding ways to find areas under curves. And what you're going to find out, strangely enough, is that there is a direct connection between the area under a curve and the guys that you already found at the end of Calc 1, which is antiderivatives. So I'm going to go through one question where we are going to estimate the area under a curve using the 5 methods that you were given. And I'm going to show you that you can use the TI-84, whatever calculator you have, to get the true area under a curve. And I'm also going to use that to estimate what the error is. So let's start off with some general things. Let's suppose we have the function f of x, and it's going to be 10 over x squared. And you're going to take this function, and we're being asked to find the area under the curve. And that would be the notation. You would read it out as the integral from 1 to 5 of 10 over x squared dx. And this would be the notation that would mean I'm going to find the area under this curve from 1 to 5. And we're going to be doing it with 8 strips. And the usual notation for that is n equals 8. So the first thing I would do is I would draw the function 10 over x squared. And it looks something like that. And I put 1 there, 2, 3, 4. There's 5. And the area I'm trying to find is this children's slide shape. Right? So I want to find the area under this curve. Now what we do is we break the shape into smaller pieces called strips. Okay, there's a strip there, there's a strip there, there's a strip there, there's a strip there. Right now I've split that shape into 4 strips, but we want 8 strips. So what we do is we need to find out, it's not too difficult, I'll put little dotted lines between them. where to cut this shape. And would you agree there's now 8 strips? The dotted ones are just to make you look a little bit different. And this guy here, for instance, would be 1.5, 2.5, 3.5, 4.5. So you draw a picture, you get a good idea of what the shape looks like. And now we move on to the second phase, which is we are going to create a table. First thing I'm going to do is get a guy who we call delta x. And delta x is going to be the width of one of these strips. Now I can look at this strip right now and tell you that it's 0.5. But how would you calculate it in general, right? Because it's not always going to be easy to draw a picture and figure out how much each width is. So the formula for doing it is b take away a over n. Now, b is that guy, a is that guy, and n is the number of strips. So what I'm going to do now is do 5 take away 1, right? 5 the finishing point, 1 the start, split by 8, and guess what? That's that 0.5 that we already knew. Right. But maybe next time it's 1 to 7, and it's not so obvious how wide the strip is. You know, maybe the strips are 0.3 wide, right? Really weird decimals that you can't do easily. There's your formula for getting how wide the strip is. Then what we do is we create that table I talked about. So we're going to have an x, the x coordinate, and f of x, the value of the function, at that x coordinate. And we're going to have 1, and then 1.5, and 2, and 2.5, and 3, and 3.5, and 4, and 4.5, and finishing at 5. Now, that table was easy. Now, I would suggest very strongly that you actually physically write this table down, because you're going to have to put in a whole load of numbers, and it's going to take you quite a long time. If you just have them scattered around it anyway, it's going to take you quite a long time to find them later on when you need them. Now, while we're at this point, let me introduce you to some new notation. This guy here, the first guy, the first x right there, he is called x0. And this guy's called x1. This is x2, 3, 4, 5, 6, 7, and 8. So if I said to you x3, you know I'm talking about the number 2.5. If I say to you the ordinate x7, you know I'm talking about 4.5. So this is a way for us to organize what we call these different values of x, right? You can see x4, for instance, is the number 3, right? The x coordinate would be 3 at that point. So far, so good. This is a numbering thing. Now, for every single one of these, we're now going to find the value of the function at this given value of x. And this involves me now showing you something you can do using your calculator. Right? People do these different ways, and that's fine. I'm going to show you. I can hit the right button. Nope, not yet. Okay, just bear with me for a few seconds more. There we go. Right, you're going to have to calculate the value of the function at 1, 1.5, all the way down to 5. Now, one way to do it would simply be just do the calculation essentially 9 times. So you do 1 divided by, not 1, sorry, 10 divided by 1 squared. And your answer would be 10. And then you do 10 divided by 1.5 squared. and you get the answer 4 point a whole load of 4s. And then you do the next one, which would be 10 divided by 2 squared, and you get the number 2.5. Now that would work, agreed? But if this function wasn't, 10 over x squared, but was something really ugly and messy, that would get pretty tiresome. So is there a better way, a more efficient way? And the answer is yes. So this is how you would really go about it, I would suggest. You press y equals, and you put in whatever the function happens to be. In this case, 10 over x squared. And that's that bit done. You then do second table setup, and you start at the first value, which in our case is 1, and you press enter. And delta table is just like delta x, so in this case 0.5, and that's that done. And then lastly, second table. And what you've got here is everybody done. So I'm just going to use that to do all the other answers.
Can you go back and show us how you did that again?
Sure.
If you can.
So press y equals, right? Y equals, and type in the function 10 over x squared. Y equals. Second table setup. Second table setup. Under table start, put the first value in your table, which is 1. Delta table, put in 0.5, right? Whatever delta x happens to be, 0.5 in this case. So start number 1, delta x 0.5. Then lastly, second table right at the end. And there's all your guys. Okay. I'm going to zoom over to my white thing so you can kind of see me fill it in as I do it. We're at 1.11, 0.816, 0.625, try to make sure I don't. Here we go. 0.4938. I don't need 38, so I'll just call that 4. And lastly, 0.4. Now, normal homework questions are much more accurate. They want you to do the answer to 6 decimal places, or even worse, 8 decimal places. Right. Now, if that's the case, you still do what I've just done here, but you don't round these numbers off as I have to 3 decimal places. You would write them down. Let's suppose I wanted 6 decimal places. You would make sure that all these numbers were accurate to 7 decimal places. Yes, 7. Always make sure that your working accuracy is 1 more than the final accuracy. So all of these would be to 7. I'm going to make my life easy and your life easy by assuming that we wanted this answer to only 2 decimal places. And for that reason, I'm only going to do my table with 3 decimal places accuracy. Now, you can do it with 20 decimal places, you can do it with 2 decimal places. The process does not change, right? So the reason I'm reducing this is for time. If you can do it with 2, you can do it with 22 decimal places. Now, each one of these guys here has its own name. The 10 is f of x0. This is f of x1. This is f of x2. This is f of x3, and so on. Excuse me. So if I said to you f of x6, you would know it's that guy, 0.2625. F of x2 would be 2.5, for instance. Now, the reason that we have these is that I'm going to show you formula for calculating left, right, trapezium, and Simpson's rule. And you need to know these guys because they're going to be in the formula. So let's start by getting L8. The formula for L8 is delta X. Now, if you want to do the left-hand endpoints, can you imagine my first strip, which is there? I have two choices. I either use the left side or the right-hand side to decide how high my strip's going to be. It's going to be a rectangular strip. So if I decide to use this side here, then my strip is going to be that one. So that's going to be f of x naught. So that fella. And then f of x1, f of x2, all the way to there. So if you notice, there's actually 9 numbers here, but we only use 8 at any given time. These are going to be the heights of the rectangle. And if you count them, there's 8 of them. And that's represented here because you finish at 7. So that is the formula for calculating L8 using the left-hand side 8 strips. So L8 is going to be delta x, is going to be 0.5. That is what delta x is equal to. And then simply, I just add up all of these guys. So what's that going to look like? It's going to look like 10, 4.444, 2.5, 1.6, 1.111, 0.816, 0.625, and 0.494. All added up. So what does that get me? L8 is 0.5 times, let's see, put in a lot of zeros here. Actually, I should probably do this in the calculator, but I'm just going to it by hand now. 4, 5, 11, 16, 20. Carry 2. 6, 7, 8, 9, 10, 9. That's 19. 5, 11, 19, 20, 26, 31, 35. 3, 4, 5, 6, 7, 8, 9, 10, 11, 21.59. And that I can do, yeah, I can do it in my head. That's 107.95. So there we go. So there is the estimate for the area under that curve. It's about 10.795. Now, if you want to find R8, well, instead of doing those guys, you miss the top one and you do the bottom guys. So if I was doing R8, my rectangle would be using this side. You see, my rectangle would be that little baby guy. And so it would be delta x, use, basically forget the top one and use everybody else. So that one, and finish with the last one. So it's going to be 0.5. And I'm going to take and add up every single one of them. And I'm going to cheat by telling you what the answer is, but essentially I would do this calculation. And there's a shortcut for it, but all I'm going to do is tell you the answer. It'll take a little bit of cheating here that you won't see, but that's fine. So if you add all of these numbers, you're basically going to get that number, which is 21.590. You're going to lose a 10. and you're going to gain a 0.4. And that little trick, it basically allows me to get the answer quickly. So it's 15.59. Which means it's going to be equal to 7.795. So I'll put some circles around here. There is L8. There is right 8. Right, do we have any questions so far?
I don't think that's the right number. 15.9 because 21.59 minus 10 is 11
Oh,
plus 0.4 should get you
you're right.
11.99.
Well caught. I want to show you what I did on my calculator. Do you see I put in plus 0.4 and not plus 0.4? So let's do the calculation the way you just said. It should be the first answer. Take away 10. And then it should be add 0.4. Not add 0.4, right? Is that what you agreed it would be?
Yes.
11, yeah. So 11.99, which is actually darn close to 6, isn't it, really? Let's be accurate about it. What would it be? Divide that by 2, and you get 5.995. Okay. It is so easy, even when you think you're doing it correctly, which I did. It's so easy, isn't it, just to forget a decimal point, as I just did, or miss a number, or write 4-2 when you meant to write 2-4. These kinds of questions are very aggravating because you know what you're doing. You don't just always get the correct answer because it's some really annoying trivial mistake. But we've now got 2 of our answers. And there's only 5, and we've done L8. I might as well write them down now. L8 is 10.795. R8 is 5.995. And I'm going to pause for a minute. And this is what the function 10 over x squared looks like. And it started here and it finished here. And I'm just going to put in a rough number of steps. When you do the left ones, these are the kind of rectangles you use. Would you agree that all of these are bigger than the area under the curve? Which means that this is an overestimate. It means that the real answer isn't as big as that. If, on the other hand, you use the right-hand side, you end up with these rectangles. And you see how these are all underneath the curve. They're all smaller. We call that an underestimate. Which means that the true answer for the area under the curve is definitely somewhere between, in this case, the 10.795 and the 5.995. Does that seem reasonable based on the shape? And I think there were some homework questions where that's what you filled in. So far, so good? Right. If there's no more questions, let's do trapezium 8. And there's one. And the next number would be 1.5, and the next number would be 2, and so on. And these are the strips. Now, sometimes we use the left-hand side, which gives me this. Sometimes for a strip, we use the right-hand side, which gives me this. But there's a third possibility. We could take the 2 endpoints and join them together with a straight line and make a funny little shape that looks like that. And that shape, this guy in here, is called a trapezium. And we can find the area of each of these. Would you agree, just by the geometry of things, isn't this going to be a more accurate answer than either of the R or the L, right? You see that joining them together with straight lines is going to improve your accuracy. And T8 is typically always going to be better than a left or a right. And there is an ugly formula for T8, which I'm not going to show you, because there is a much nicer formula. Can you trust me that if you broke this shape into funny little trapeziums and you found the area of all those trapeziums, the answer that you would get would be the same as this, which was kind of remarkable, but very nice. It's essential, isn't it, the average between the two? Now, if someone was saying to you, hey, I'd like to get a better estimate, but all I've got to work with are these two numbers, would it seem reasonable that if you did the average of them, that might be a little bit better than either of them? Because this one's too big and this one's too small. So, you know, Goldilocks, don't you want one in the middle that's just right? Well, the one in the middle, you get this guy. So all we need to do is take the left, which is 10.795, and add 5.995 and divide everybody by 2. And I'm nipping over at the calculator. You just trust me that I'm doing this and hopefully not hitting the wrong button. And put a little bracket around it, make sure I do it in the right order. 10.795 add 5.995 and then finish the brackets and divide by 2, and the answer, let's try that again, 10.795 add 5.995, now divide by 2, and I get a much nicer answer. Okay, and the answer that I got for T8 is 8.395. So we now have created 3 estimates. The left one says it's about 10.795. You know that's too big. The right one says that it's 5.995. You can tell by looking at the picture that's too small. We can do a trapezium, which is 8.395, and that looks pretty good. But can we do better? Well, the answer is yes, we can. There are 2 more methods that we are going to use. And the next method I'm going to show you how to use is Simpson's rule. Simpson's rule basically does the same issue as before. If you take one typical strip, whatever it might be, we can use the left side, we can use the right side, or we can use trapezium, right? So what does Simpson's do? Simpson's takes a start and a finish, and it joins this point to this point with the nicest quadratic curve that you can find. And then we find the area. So it's a little bit of a refinement. Instead of a straight line from the start to finish, we do a curve from the start to the finish. And the curve we use is a quadratic. And there's a lot of intricate math that we don't need to worry about. And it works. It gives us an even better answer than any of these guys. In fact, in the order that I've written these guys, these 2 are horrible unless you do lots of strips. This will be better than either of these, and this guy will be better than everybody. So you might think, why didn't we just do Simpson's rule instead of all the others? And there's a good argument for that. Why didn't we just do it? And the main reason is, well, a couple of reasons, I suspect. The first one is that Simpson's rule is ugly. There is no way around it. The formula for Simpson's rule is ugly and complex. And that is a very big disadvantage. It's hard enough trying to do these questions when the number or the rule you're using is just add them together. It's really difficult when the rule changes all over the place. So that's the major first reason, I think. And the second reason is that if you think of left and right strips, even although they're not very accurate, it does kind of visually make sense that it would do a job, right? It would work. It's not so obvious how you could make a curve from here to here. And even if you could make such a curve, what that curve was and would it be any good? So there's a kind of, it's harder to believe that it's true. So let me show you the ugly formula to get S8. Delta X, which is the width of the strip, divided by 3. So that's the first little change. And then it gets really messy. All the other rules that we've used only use some of the numbers. We either use the first 8 or the last 8, or we average them out, right? But in this one, you use that guy. Okay, that seems okay. Then, oh, wait a minute. You use 4 of that guy. And then, okay. Oh, and now you use 2 of that guy. And then you use 4 of this guy. And then 2 of this guy. And then 4 of that guy. And then 2 of this guy. Then 4 of that guy. And then you finish with just 1 of the last guy. Would you agree that's a pretty ugly looking thing? Over here, I'm going to add a little thing to my table. 1 of these, 4 of these, 2 of these, 4 of these, 2 of these, 4 of these, 2 of these, 4 of these, and 1 of these. And that little extra bit is just to remind me what to multiply each one of these fellas by. So delta X is 0.5 divided by 3. And it's going to be 1 of this fella, right? So it's going to be a 10. And then it's going to be 4 lots of 4.444. And then 2 lots of 2.5. And then 4 lots of 1.6. And then 2 lots of 1.111. And 4 lots of 0.816. And 2 lots of 0.625. Almost done. And then 4 lots of 0.494. And finally 1 lot of 0.4. Now, typically you wouldn't write this down, but these are for notes so you can see where things are coming from. So this guy's 10. And now each one that we're about to do, I'm just going over to my calculator. So 4 times 4 point, I think there was actually 3 4s there, is going to be equal to 17.776. That guy's 5. That guy is 6.4. That guy is 2.222. That guy is a calculator. So 4 times 0.816. That's 3.264. That guy is, check it with a calculator just to be sure. 2 times 0.625. $1.25. That's is that a whole load of 4s? Oh, 494. Okay. So it's going to be 4 times that. And finish with 0.4. Whoa. Okay, so it's going to be 0.5 over 3. Let's try this. 6, 7, 8, 9, 10, 11, 12, 18. 7, 8, 9, 15, 20, 27. Carry a 2. 9, 13, 14, 15, 16, 17, 18, 19, 20, 32. 3, 4, 5. No. 3, 10, 18, 24, 26, 27, 28, 29, 30, 31. 3, 4, 5. There we go. I hope that's right. The method is, there's no guarantee I can count. So I'm putting what I have in front of me into the calculator as we speak. So 0.5 times 51.278. Then I'll divide everything by 3. And I'm wrong. I think it's at the last digit I was wrong. 7, 2, 9, 14, 20, 2, 3, 4, 5, 6, 7, 28, 38, 40. That's a big difference. Oh, shooting space. Right, if you're just going to have to wait a minute, I'm just going to type it all into the calculator and let it figure it out. I know the answer should be around about 8 point something, and the answer I got was definitely not that. And I can kind of sympathize with what probably was happening for some of you when you were doing the same questions that I am. Okay, so I now have 0.5, 48.378 divided by 3. So let's check that now. So if I multiply that guy by 0.5, and then I divide it by 3, I got the answer I was looking for. 8.063. I'm very happy with that because that's a good answer. Right, so I guess the moral of the story is you've got to be careful. Now, there's one method called midpoint 8 that I haven't done yet. And I want to do something else first. And if I've got time, I'll do midpoint 8. If I don't, the only difference in midpoint 8 is that your table will have 8 numbers in it, not 9. And the 8 numbers that you will get, the x coordinates will be, the first one will be halfway between 1 and 1.5. So 1.25, and then 1.75, and then 2.25, and so on. And once you've built that table, the midpoint rule is the same as T8 and R8. You just add up the values and multiply by delta x. So that's how the midpoint would work if you were going to do it. So we now have four different estimates. What we would like to know next is what is the exact answer, so we can look at them and say, hey, you're pretty good and you're horrible. And the best and simplest way to do that, and it's a bit of a cheat, but it works. Okay, Griffin, gotcha. So what we're going to do now is show you how to get the exact value for that particular one, right? Using your calculator. So, first thing, y equals, well, it's already there. Type in 10 over x squared. So y equals 10 over x squared. Hit window and start at 1 and finish at 5, because the integral, the area was from 1 to 5. And then second calc. Choose option 7, which is area under the curve option. And it will draw a nice little picture. Kind of nice of them. And it'll go and ask you for the lower bound, which is 1. Press enter. Then the upper bound, which in this case is 5. Press enter. And it'll do a little animation for you. And at the bottom, it'll tell us the answer. And the answer is 8. And that's how quick it can be. And before you do any of those questions, if you've still got some to do, because I've extended the homework for another week because of some issues that people are having, you can do that so that you know your L8 and your R8 and your T8 and definitely your S8 should be close to that number. Now, S8 definitely should be close, right? And so should the T. The left and the right could be a bit out. As you can see, your 5 and 10 are not great, but they're not 50 and 100, right? They're not definitely wrong. So the exact value for the integral from 1 to 5 of 10 over x squared was 8. So we would now sometimes like to know how good or bad are our estimates. And there's a thing called the error. And EL is the error that you get in using the left endpoints, in this case L8. And the error is the real value take away L8. So it would be 8 subtract this number. And so the error is negative 2.795. Now, if you wanted to do the error of Simpson's rule, it would be 8 take away this number, which would be negative 0.063. If you wanted to do the error in using the right guy, it would be 8 take away 5.995. So that would be 2.005. And so these represent how far away the estimate is from the true value, which in this case is 8. And it is pretty much guaranteed that when you do these questions, the L8 and the R8 are the worst case. Sometimes this is better than that, sometimes that's better than this, but in general, they're worse than anybody else. The next one is trapezium 8. Trapezium 8 is always going to be better than these two. The next one after trapezium 8 is midpoint 8. And the last one, the most accurate, is going to be Simpson's 8. Okay, we've kind of reached the natural endpoint. So what I'd like you to do for attendance